So in this question here, I've got a sequence here, and it's a bit of an odd looking sequence. I've got 3n squared divided by n squared plus 2. That's what defines my nth term. Now I want to know which term is 32 over 11 and what happens as n approaches infinity. Okay, let's have a look at the first bit. Which term is 32 over 11? So the easiest way to do that is just to set this to 32 over 11. Let's do that. So 3n squared over n squared plus 2 equals 32 over 11. Okay, now what we can do here is just use our rules for fractions when we're trying to simplify. So let's get both sides and multiply by 11. Okay, so multiply this one by 11. I'll have 33n squared in my numerator. N squared plus 2 will stay as it is. And then times this by 11, I'll just have 32. Okay, now this time I need to get rid of n squared plus 2. That's the next thing I need to do. So now I need to multiply both sides by n squared plus 2. So times by n squared plus 2. So if I multiply this side by n squared plus 2, this will cancel. I'll just be left with my numerator. So now I've got 33n squared. And then times this side by n squared plus 2 times 32. I'll have 32 n squared plus 2. Okay, now we're getting somewhere now. So now we can hopefully isolate the n squared. Before I do that, I need to get rid of this brackets. So I've got 33 n squared. Foil this one out. I've got 32 n squared. 32 times 2, 64. Okay, now I can get this n squared over here, and I've got 64 on its own. So let's subtract 32n squared from both sides. So now that will just leave me with n squared. This one will cancel and I'll have it set to 64. Okay, that's really handy. I've got a square number here and a square term here. So now take square root on both sides. So now this will give me n, and the square root of 64 is plus or minus 8. So that's important there. I've got a plus and a minus. Well, as this is a sequence with nth terms, we don't have the negative 8 as a value that we use in there. We only need the positive version. So therefore, we can deduce that the minus 8 is not needed. So this is therefore the 8th term. So that would take care of that. Okay, so now what happens as this approaches infinity? Well, if I just write out my sequence, 3n squared over n squared plus 2, and now what I want to do is take the limit as n approaches infinity. So the limit as n approaches infinity of all of this. Now what I would do here, I would divide every term in this fraction by n squared. That would tell me what happens as this approaches infinity. So now I've got the limit as n approaches infinity, 3n squared divided by n squared. And then here, divide each one of these individually, not the whole denominator. So now I've got n squared divided by n squared plus 2 over n squared. Okay, now before we even look at what happens as this approaches infinity, I can simplify this off and cancel out terms. So the limit as n approaches infinity, 3n squared divided by n squared, that gives me 3. N squared divided by n squared gives me 1. And then I've got 2 over n squared. Now 2 over n squared, let's just have a look at what happens here. Let's just write it up here. 2 over n squared. Now if n equals 2, I've got 2 over 4. So if n equals 2, I've got 2 over 4. If n equals 20, I've got 2 over 20 squared, which is 400. Now if n equals 200, I've got 2 over 40,000. Now you'll see here, that's a half. That's quite a small fraction, 1 over 200. This one here is 1 over 20,000. So the bigger n gets, the closer it gets to 0. So as n approaches infinity, this 2 divided by n squared will disappear to a 0. So therefore, my limit will just be my constants, because they will never change as n approaches infinity. Constants, as n approaches infinity, 3 is still 3. Same with 1. So therefore, my limit as n approaches infinity is 3. So what happens as n approaches infinity? The sequence approaches 3. So I'll just write that, let's write that here. The sequence approaches 3. So I'm going to write that as my conclusion to this part here. Okay.